Apollo 11 badge that I wore. That was my first time. 40 years ago, this July, I've been supporting public affairs. Now, and I'm giving you a little background so that you'll understand. Well, you'll understand in a few minutes why. I started in Huntsville with Varner von Braun's group, worked on Explorer 1. Judy's from Huntsville.
You're gonna be the herder, right?
I'll be the herder. I'll be the.
One of the things we unfortunately cannot show you today is the payload bay, which is really kind of cool when you get up in there. So what we're gonna have to settle for the pictures. We're gonna be at the ground level, can't go up and show you all that stuff. But pretty much the payload bay empty. This is what it looks like right now. It's an empty payload bay. It's 60 feet long, 15 feet across. Pretty much the workload of what we do. We try to bring up payload and satellites and all that stuff. So we just finished a Hubble mission, last service repair mission of Hubble. Just the other day, we took out all of the payload from that. You've seen all the gold payload, the big ring, the whole the satellite, all of that went out just the other day. So we've got a real clean bay. What we're doing is getting ready to fly the STS-129 mission to the International Space Station. So we'll load up those payloads for that flight. What you've got with the payload bay is essentially a miniature clean room. You see all the guys have to wear the money suits. And in fact, this is the STS-125 crew when they're getting ready. The astronauts always take a look around the payload bay before they go fly. It's one of our training objectives. They kind of get in there, really look around, especially the guys that go out into the bay on the extra vehicular activity, the suits. They really have to know their way around there because you don't want to learn on orbit. Hey, what's this thing in my way? So this gives them the opportunity to come in and kind of get a lay of the land, so to speak.
So the doors in the cockpit directly back into the bay?
Yes. Let's see. This is your best
Is that how you do all the EVA stuff?
Yeah, this is the external airlock. So this was what's interesting about the Hubble flight we just flew. They flew 5 EVA that we're planning to ever see. All the rest come out of ISS. So we dock here to the International Space Station. We do all of our EVAs from the space station. So there are no more plans to fly any more shuttle-based EVAs. So to see 5 in a row was just absolutely incredible. So let's see, this is the back of the ship. Here to look at it like this. Payload bay doors open, multiple pods here, the vertical stabilizer here, radiator doors, what we use for active cooling. We've got the orbital boom sensor here, big stick that we use to survey the underbelly of the vehicle. And then this is the robotic arm. And one last thing to show you the EVA that we're planning to ever see. All the rest come out of ISS. So we dock here to the International Space Station. We do all of our EVAs from the space station. So there are no more plans to fly any more shuttle-based EVAs. So to see 5 in a row was just absolutely incredible. So let's see, this is the back of the ship. Here to look at it like this. Payload bay doors open, multiple pods here, the vertical stabilizer here, radiator doors, what we use for active cooling. We've got the orbital boom sensor here, big stick that we use to survey the underbelly of the vehicle. And then this is the robotic arm. And one last thing to show you here. Assessing the tile all the way around. Those are just graphics we have to do. We don't have to necessarily replace all of them, but they have to look at them and look at where every tile is different. In fact, some tile are thicker, some can sustain more damage than others. Where is that? What type of heating it sees as to what type of damage it can sustain. And then compare. We compare this. This is the nose, or the space shuttle up here is the nose cap, which is made out of reinforced carbon. It's gray material, solid gray. That is, in fact, what they're making is, Porsche is making some of their brakes out of reinforced carbon.
So is it carbon with epoxy? What is the...
Carbon fiber with epoxy. And it's a manual process to make these so that the cost is enormous. And especially when you consider that all 22 panels on each wing, 44 panels, we'll see those in a minute, are making the same process, a manual process to lay each layer over a mold of a wing shape.
Is it done in a vacuum also, or is it just like it's just laid out?
Handmade.
Yeah.
So the nose cap is truly a nose cap, just in how you would expect it to look, and then the panels underneath it are the whole thermal protection system.
By the time it lands. Right. Oh, yeah. Oh, okay.
Gravity's not working for you. You've got various systems, and it's kind of glued on with an RTV and epoxy, and that's what's holding it in place. Now, for show and tell, you guys might want to, let's see. This is a sample tile that we use for testing. This is not a flown tile, so don't worry about it. But this gives you an example of what tile feels like.
Very lightweight.
Very lightweight. Very lightweight. Yeah. Yeah. Some tiles even thicker. See, look. See, look. Some tiles even thicker. He's got them over there. That's okay. And some tiles even thinner. We've got some tile that's about an inch thick.
Is it based on where it is on the...
It's based on where it's at on the vehicle as to what heating it is. We've got different heating in different regions of the vehicle. So you've got, depending on where the thermal profile is, the thicker the tile, the more it can withstand, obviously.
Paint
Is it blanket?
is actually thin. It's a blanket. The whole external side of the orbiter is controlled by some kind of thermal protection.
Yes, you absolutely need thermal protection.
So you got fib, you got
All these materials, they got wet. The tile itself, the silica structure that we talked about, I'm going to try to show you this. I'm going to give you that.
Okay.
I want you to squirt some in the bottom. Squirt some in the bottom of the bag. Give me some more, give me some more. Okay, that's good. Now, I probably shouldn't have done this, but what you'll notice with the water is it's going to quickly absorb right into this.
Yes.
I mean, that sucked it up like a sponge, right? So you can imagine all of these, if it's just sucking the stuff up as a sponge, how heavy it is. You can feel that. Pass that around, that would be a wet tile.
Yeah, that's a wet tile.
So here's what we have to do. We have to waterproof it. That's just not absorbing the water, is it?
Correct.
So we have to impregnate this. I think it's with nitrate magnesium compound that we put, kind of saturate the environment and put it in a vacuum so that it really sucks it up. Try to cut this tile in half, it would still be just as waterproof. It's not an exterior coating, it's impregnated through the whole material. So that is just not absorbing the water compared to what the other one did. So that you can pass around and see how lightweight that is. Compared to the tile that just sucked up all that water. So we have to waterproof each and every tile. And we also have to put on a waterproofing agent on these, so we don't want these sorting out. So you got to waterproof this whole vehicle. Isn't that fun?
What agent do you use on something that's
Same type of thing, or it's flexible?
It's a different tires, not as beefy as what you'd expect. So this is kind of designed more based on the DC9 at the time, or DC10. So that's kind of why we have the non-beefy.
Is it currently supported by these two jacks here?
Actually, there are 4 jacks that are holding up right now. These two 4-stage jacks right here. They're holding it up right by the set. The other 2 jack points are right up there. So there's yellow jacks that are holding up the side. In a minute, but the space shuttle is attached to the external tank by 3 points. 2 of which are here. One is over there, the inverted bowl, the salad bowl, which is right by that jack. So there's one on the other side. There are 2 umbilical areas, and then one is up front, up by the nose landing here. What this area is this is the liquid oxygen umbilical, and you can see that big 17-inch line right there. That is where the external tank, where its line is mated up to it. So this 17-inch line, liquid oxygen on this side, liquid hydrogen on the other side. Those are used to feed propellant from the external tank into the main engines. And we probably can't get a view of the main engines, but we'll give it a shot. But this is actually a pretty interesting mechanism because this umbilical plate that you see here actually extends down to meet with the external tank, and then once the external tank is separated, we've got big bolts. We stick through the salad bowl. We separate from the tank, we shear that bolt, pyrotechnic. The tank drops off. Actually, the tank is ordered. You don't really have that on the spaceship. You've only got one shot of the delta wing. So you can see that if you were in flight, you would see that aero surface is moving at different positions, different rates. And also you've got this large body flap right here that protects the main engines. So during entry, the body flap will kind of move a little bit to set trim, but really these elevons are what's really driving what's really doing the work. So if you need to, obviously if you need a big roll command, you can move the outer elevons.
We're colliding.
Oh,
It's okay. We can give some out to us.
All right, I'm sorry. Okay, so I want to show you guys the main engine back here. You can see the back of the left main engine there, the right main engine you can't see as well. And then there's one that's the center engine just above it. So those would be the bells of the main engine. The base of the space engine. The main engine is nozzle sticking out. We got we had talked about pulling carrier panels. Carrier panels are the big long blocks that you see. Some of them are open, some of them are still installed with the big ceramic insert right there. That's what we used to put it on. So we took these off. What we're doing right now is setting up what we call thermography. Thermography is a neat way to, and we'll do that over the weekend. So this is actually kind of cool. So of the 22 panels, let me see. This is probably about the peak heating rate.
This is something like this. Oh, this is different. This is the VAD.
Yeah.
Also, the yellow clips just don't work.
It's almost like that, except it's in. You can see this in the horizontal.